Okay, for this video, I'm going to show you how to calculate for specific heat, which is what today's assignment entails. So make sure that you take the notes where it includes the information that I'm covering right now. The first thing I want you to keep in mind is that the formula is Q, which stands for the heat energy, is equal to C. Sometimes you also see it as CP, and that's specific heat times mass times the change in temperature. Okay, so just so you know, and it tells you on the PowerPoint that that little triangle looking thing means change in temperature. Okay, in order to figure out what the numbers or what variables those numbers are, you can always look at the units. So Q, you're going to see a number that's expressed in joules or kilojoules, but for the most part, you'll see it in joules. Specific heat, you'll see a number that has joules over grams times degrees Celsius as its unit. Mass, as usual, you'll see it expressed in grams. And then obviously temperature, you'll see it expressed in Celsius. It does say Kelvin, but for the most part, it'll be in Celsius. Okay, the other thing is that in the notes, you also have how it's already been manipulated. That formula has already been changed for you. So if you want to solve for Q, that's the original formula. It's going to be mass times specific heat times delta T. If you want to find mass, it's Q, which is heat energy, divided by specific heat times change in temperature. And then if you want to find specific heat, it'll be Q, which is heat energy, divided by mass times change in temperature. And then if you want to find the change in temperature, or delta T, it's going to be Q over mass times specific heat. Okay, so we're going to take a look at these examples are already done for you. So I'm going to let you go back and look at them as a reference, but I'm going to go ahead and practice with you by doing some of the problems from the independent practice. Okay, so on the first one, it's asking what is the specific heat of a substance that absorbs 2,500 joules of heat when a sample of 100 grams of a substance increases in temperature from 10 degrees Celsius to 70 degrees Celsius. So first and foremost, I want you to take note that they're asking you what is a specific heat. So right off the bat, they're already telling you that's what we want you to find. So here's specific heat, and that's pretty much going to be our X or our question mark, what we're trying to find. It then tells you that it absorbs 2,500 joules. Now, if you remember from the previous slides that we talked about, I did mention that if you have a number that's expressed in joules, that's going to represent Q. So going back to that question again, that means that they're giving you the Q, and that is 2,500 joules, or J for joules. And then it goes on to say that in a sample of 100 grams, okay, grams is the unit of measurement for mass, so we're going to say that it is 100 grams. And then change in temperature. For change in temperature, it's always going to be your final temperature minus your initial temperature. So your ending temperature minus your starting temperature. So it tells you that it increases from 10 degrees to 70 degrees. So 70 degrees is your ending temperature minus your starting temperature, which is 10 degrees. So the total change in temperature is 60 degrees Celsius. Okay, so now that I have that, I'm going to select the formula that is for specific heat. So going back to that slide on the manipulated formulas, we're going to use a one for specific heat, which is this one, and it's going to be Q over M times delta T. So that equals to Q over M times delta T. Okay, and then for the work, we're simply going to substitute the information or the numerical values. So specific heat is equal to Q. We said Q is 2,500 joules. and then divided by mass. So mass is 100 grams. And then change in temperature, which is 60 degrees Celsius. Okay, from this point on, I'm going to go ahead and calculate it here on the side. So I've got 2,500 divided by the product of 100 times 60, which is 6,000. And that's going to give me a total of 0.41666, but I'm going to round to the nearest hundred, so it's 0.42. And for the units, you're going to see that these are different units. They can't cancel each other out, so it's going to be joules over grams times degrees Celsius. And if you look at the notes as well, in the notes, when we were talking about what units are for specific heat, you will find that the units for specific heat are going to be joules over grams times degrees Celsius. So that makes perfect sense on why those were the units that we got. So that's how you would go about finding or solving for specific heat using the Q equals M delta TCP. We're going to do one more. Okay, on this one, it's asking you to find Q. In this case, you would just take all your values and multiply them together. So I'm going to kind of bypass that one and maybe do something a little different, something where the formula is not really just multiplying it. It'll include multiplying and dividing. So we're going to go ahead and do number 3, which is how many grams of water would require 2,200 joules of heat to raise its temperature from 34 degrees Celsius to 100 degrees Celsius. And then it goes to tell you that the specific heat of water is 4.184 joules over grams times degrees Celsius. So the very first thing you're going to do is you're going to go ahead and place the information on the left-hand side of what is given to you. So it's asking you how many grams of water. So first and foremost, what are they asking you to find? Mass, because grams is a unit of measurement for mass. So we're going to put a little question mark here. And then it says that it would require 2,200 joules. So if you remember from even the last one, joules is a unit of measurement for Q. So I know that Q is 2,200 joules. And it says to raise the temperature from 34 to 100 degrees Celsius. So that's going to be my change in temperature. So remember, it's T final minus T initial. So it's going to be 100 degrees Celsius minus 34 degrees Celsius. And then that adds, or that's actually going to be subtracted, and it's going to end up being 66 degrees Celsius. Okay. And then last but not least, it gives you the specific heat, which is of water, which is 4.184 joules over grams times degrees Celsius. Okay, so we are solving for M. And if we look at the formulas, it does say that M is going to be Q over delta T times CP. Okay. So I'm just going to substitute all the values for those variables. So I'm going to go ahead and put it in the work section. So that's going to be mass is equal to Q, which is 2,200 joules, divided by the change in temperature, which is 66 degrees Celsius, times the specific heat, which is 4.184 joules over grams times degrees Celsius. So I'm going to do the math. So it's going to be 2,200. If all the units are messing you up, they're mixing you up, just understand that this is what you're doing. You're doing 2,200 and then 66 times 4.184. Okay, so that's essentially what you're doing here. So I'm going to go ahead and multiply the bottom. So 66 times 4.184. That's going to give me 276.144. And obviously I have the 2,200. So now I can divide the top by the bottom. So 2,200 divided by 276.144. And that's going to give me 7.0 966, so that rounds to 7.97. As far as the units, it is mass, and if you looked at those slides with the notes, it tells you masses in grams, but I can also show you how it's going to cancel out. This joules cancels with this joules. Then we have Celsius canceling this Celsius. So really the only thing you have left over is grams, which makes sense. And that is our answer. So this is how you're going to do the assignment for today.